and the speeding motorist happens to be going at 132 kilometers an hour. And then a stationary police car spots this speeding motorist and begins pursuit 4 seconds after the car has passed. And we know that this police car accelerates at 5 meters a second squared for 8 seconds. The question is, at what time will the cop car catch up? So, first thing I'll do is the 132, I'll convert that into meters per second, which will give me 36.67 meters per second. Okay. Now to do a question like this, you will be using the most useful of the three graphs, which is the velocity time graph. I'm going to use green for the speeding motorist, and we use blue for the police car. So the speeding motorist is going at 36.67 meters per second. The whole time his velocity does not change. It's 36.67 meters per second and it doesn't change. The police car, on the other hand, does not begin pursuit for 4 seconds. After it does begin pursuit after 4 seconds, it accelerates for 8 seconds. So the total time on the x-axis would be 12 seconds by now. And we know that during its acceleration process, it gets to a speed of 40 meters per second. How do we know that? We know if you're accelerating at 8 seconds at 5 meters per second squared, you're actually traveling at 40 meters per second at the end of those 8 seconds. After this point, the police car holds its velocity as well and it doesn't change. Now, because the police car is going faster than the speeding motorist, after some point they should catch up somewhere here. So what's that? To work this question out, you need to know two things. We need to find out the area under the graph. And on a velocity time graph, the area under the graph gives you displacement. So the first thing I want to know is how far has this speeding motorist travelled when the whole thing's at 12? The speeding motorist has travelled at that time. Area is equal to length times width, which is 439.99 meters, approximately 440 meters. On the other hand, we need to now know what has the police car covered in its acceleration time, which is this part in here. And the area of that would be half base times height, because it's a triangle. And half, the base is 8 and the height is 40, which gives us 160 meters. So now we've found out the fact that at 12 seconds, the speeding motorist has covered 440 meters from the point where the police car detected the speed, and at the 12-second mark, the police car has covered 160 meters because it's been accelerating in pursuit. So at this point, the difference between the two is down to 280 meters. That's what the police car now needs to chase down. This is the distance the police car now needs to chase down. Now, to chase this distance down, the difference in the two velocities must be considered, which is this here. And the difference in the two speeds is 40 minus 36.67, which gives us 3.33 meters per second. So now I know that the distance to be covered is 180 meters. The speed, or the positive speed the police car is going by, is 3.33 meters per second. Because the speeding motorist is still going at his assigned speed, the police car isn't changing its speed either, so this is the constant difference that we have. So we use this triangle to find time. We go distance divided by speed, and that gives us 84.8 seconds. Now the question was, what's the total time the police car takes? The total time means after it is accelerated and the point it took 4 seconds to start up, after that point it took 84 seconds to chase down the car. So we have to add 12 seconds to this question answer, and we get 96.85 seconds. After this time, the police car has chased, or at least met up with the speeding motorist. Hope this helps.